Thank you for that riveting story, Bob. In other news, researchers have observed a strange frequency coming from space that could change the way we survey the sky. Not only that, the discovery was almost entirely by accident. A group of students working under the tutelage of Dr. Natasha Hurley Walker was conducting a survey of the sky using one of Earth's most powerful radio telescopes called Galactic and Extragalactic All-Sky MWA Extended, or as its friends call it, GLEAM-X. GLEAM-X can detect frequencies from 72 to 231 megahertz, avoiding the 137 megahertz because of satellite interference. It also covers 30,000 square feet of sky, and each antenna is equipped with a low noise amplifier, which amplify oncoming signals. This allows scientists to explore the galaxy in more detail than ever. While conducting this survey, the researchers stumbled upon a signal that they didn't recognize. It was polarized radio frequency that lasted for about 1 minute and happened every 18 minutes and 18 seconds. It went on for several months before stopping in March of 2018. Scientists named it GLEAM-X JI 62759.5-52350.4.3. Personally, I would have gone with Glenda. Much snappier. Now, I know what you're thinking. Could this finally be alien life communicating with us? Well, unfortunately for all my sci-fi fans out there tonight, the answer is probably not.
Wah, wah.
However, scientists do have some pretty good ideas about what it might actually be. At first, some researchers postulated that it could be a galactic center radio transient, but with a little more digging, they found that the signal was actually identified as being about 4,000 light years away, rendering this theory impossible. Currently, the leading theory is that some sort of magnetar. Magnetars are a subclass of neutron star that release more energy in a second than the sun does in 1,000 years. However, these are very rare and only 30 or so have been spotted in the Milky Way. Ultra-long period magnetars have rotational times of several minutes, and if this were one of them, it would be one of the slowest they've discovered yet. However, that doesn't rule this theory out. Given that the signal stopped shortly after it began being observed, the exceptionally slow rotational time could be attributed to it losing speed throughout its life. The magnetic force on the signal adds credibility to this theory. Because scientists are still trying to classify this signal, they're using a lot of comparative methods to try and classify it. For example, as previously stated, this frequency is widely believed to have originated from a magnetar. However, some scientists have pointed out that in all of the previously observed magnetars, only 5 of them have emitted radio signals, and have only done so after X-ray outbursts, which were not exhibited in this case. The X-ray emission in this case is fainter than all but 2 magnetars previously observed. So, what let GLEAM-X pick up this hitherto unheard of frequency? Well, most equipment used for surveys is designed to tune out the noise of the telescope itself, rendering it useless in detecting faint, long-period sources. Because GLEAM-X is equipped with low noise amplifiers, it may help us find more frequencies like this in the future. Some have hypothesized that the radio and X-ray frequencies are more similar to those of a white dwarf during a moment of inertia. In order to prove this, scientists would have to collect more data on the ultraviolet and infrared emissions that we don't currently have this information available. This discovery also proves that it is, quote, possible to anchor such strong magnetic fields at the core crust boundary of a neutron star, and the energy of field dissipation can explain the observed luminosity, both radio and X-ray, of its source. In layman's terms, scientists have a lot of past ideas that they need to revisit to determine which can hold true under the weight of this new discovery. The discovery of this source has led scientists to wonder what else may be hiding from their surveys in low frequency ranges. No survey has been done to detect unknown intervals of this length, as all known pulsars and magnetars rotate in less than 10 seconds. Thank you, ladies and gentlemen, that was my time.